And welcome back, students. Let's get into programming with inheritance and start off by talking about access to a refined base method. So a quick tip to get us started here, static methods are inherited. Static variables in a base class are inherited by any derived classes, just like non-static variables would be. Static variables are also inherited. The modifiers of public, private, and protected and package access have the same meaning for static variables as they do for instance variables. Also, another tip, let's talk about is a versus has a. Earlier in this chapter, we defined a derived class called hourly employee using the class employee as the base class. In such a case, an object of the derived class, hourly employee, is also an instance of the class employee, or more simply, that an hourly employee is an employee, which we've talked about previously. This, of course, if you remember, was an example of the is a relationship between classes. It is one way to make a more complex class out of a simple class, because you can extend the class. We did hourly employee, we did salaried employee. In one of our labs, we did a commissioned employee. Another way to make a more complex out of a simple class is known as the has-a relationship. For example, the class employee defined earlier has an instance variable of the class type date. We express this relationship by saying employee has a date. By using the has-a relationship to build a class, such as building class employee by using date as an instance variable, it is often called composition. So you can kind of think about this as like where you have whereas one of your parameters, rather than just being a primitive type, might be another class object. So that would be a good way to think about how has-a works. Now, because the class hourly employee inherits the instance variable of type date from the class employee, it is also correct to say that an hourly employee has a date. Thus, an hourly employee is an employee and it has a date. Now, in this case, it's a date object. All right, access to a redefined method. Suppose you redefine a method so that it has a different definition in the derived class from what it has in the base class. The definition that was given in the base class is not completely lost to the derived class objects. However, we want to invoke the version of the method given in the base class with an object in the derived class. We need some way to say use the definition of this method as given in the base class, even though I am an object belonging to the derived class. Now the keyword you're going to use, of course, is super. Hey, we've seen this word before. All right, just like as if it was a calling object, we're going to use super. So let's look at our toString method of the class hourly employee, which was defined as follows. All right, remember we had to use get name and get hire date. All right, which we had changed from originally in the employee class, which is name and hire date. And of course, this is the overwritten method. All right, you also notice that in the new method, we added in wage rate and per hour hours. So those have been added, so it's been redefined. Now, we can use the version of the method toString defined in the base class employee to simplify the definition of the method toString in the derived class hourly employee. Now, the following is the equivalent way to define toString in the derived class hourly employee. Public string toString, return super.toString, wage rate per hour. Because you notice this right here, if you look, this super.toString is really just calling this right here. So it's going to return name plus hire date toString. Now the expression super.toString is an invocation of the method toString using the definition of toString given in the base class employee. You can only use super in this way within the definition of a method in a derived class. So it has to be in a derived class. You can't do this in the base. Outside of the definition of the derived class, you cannot invoke an overridden method of the base class using an object of the derived class. So another way to think about this is that you're invoking the overridden method. So you have to use a super call in order to invoke the overridden method. Remember, super, you can only do it in the derived class. You cannot do super calls in the base class, just like we talked about when we first talked about, the super constructors. Now, a quick pitfall. You cannot use multiple supers. As we already noted, within the definition of method of a derived class, you can call an overridden method of the base class by prefacing the method name with super dot and then whatever it is. It's like super.toString, for example, super.equals, whatever. However, you cannot repeat the use of super to invoke a method from some ancestor class other than a direct parent. So it has to be pretty much just the class immediately above it. You can't like go, oh, I'm going to invoke the class that was, 3 pairings back. No, it can only be the direct parent, the direct ancestor. So for example, suppose that the class employee was derived from the class person, and the class hourly employee is derived from the class employee. You might think that you can invoke a method of the class person within the definition of the class hourly employee by using super.super, such as super.super toString. Well, this is actually illegal, right? As the comment indicates, it is illegal to have multiple supers within inside of Java. So can't use super.super. Sorry, it doesn't work. It'd be kind of convenient, but you can't do this. So you can only use the immediate super call. Otherwise, you're going to have to come up with a different way of using that method. All right, that's going to be it for today, folks. So until next time.